Hello dear students, how are you? I am Vivek Sharma, your mathematics teacher. I teach class 11th in your school. In this video lecture, we will study about the concepts of chapter number 10 straight lines. Before starting this video lecture, please like, share and subscribe my YouTube channel. So let us start our chapter number 10 straight lines. Before understanding the concept of slope of a line, we need to understand the meaning of angle of inclination. An angle of inclination of a line is the angle made by the line with the positive direction of x-axis and measured anti-clockwise. In figure, the inclinations of AB and CD are theta 1 and theta 2. This is the figure, this is x-axis and this is the y-axis. This is the line A, B and its inclination is theta 1, and this is the line CD and its inclination is theta 2. This concept will help to understand the concept of slope of a line. As we have understood the meaning of angle of inclination, let us come on the concept of slope of a line. What is the meaning of slope of a line? The slope of a line is the tangent of the angle which the line makes with the positive direction of x-axis and measured anti-clockwise. Here, the slope of a line is represented by m. Therefore, m is equal to tan theta, where theta is the angle made by a line in the anti-clockwise direction from x-axis. We can understand by diagram. Here this is the line, this is the angle theta. Here this line makes an angle theta with the positive x-axis. So here this theta is the angle made by the line in the anti-clockwise direction from x-axis. So by this diagram we can understand the meaning of slope of a line again is the tangent of the angle which the line makes with the positive direction of x-axis and measured anti-clockwise. And we denote our slope of a line by m equal to tan theta. So here m is equal to tan theta is called as the slope of a line. Now let us come on some new concepts. Here we need to understand some new things, that if a line is parallel to x-axis, so in that case, that is theta is equal to 0. It implies m equal to tan 0, where is equal to 0. That means the slope of a line will be 0. So this case applies in that case when our line L will parallel to x-axis. Now let us come on the second observation. If a line is parallel to y-axis, so it is perpendicular to x-axis, means this is our axis and this is the line which is parallel to y-axis and perpendicular to x-axis. Okay, so in that case our theta is equal to 90. It means m is equal to 1090 or 1090 is equal to not defined. So in that case our slope will be not defined. Now let us come on the new topic of slope of a line passing through 2 points. Here we will find the slope of a line which passes through two given points. First of all, we draw coordinate axis. We take a line. This is y-axis. This is the line which makes an angle theta with the positive x-axis. So we consider 2 points A and B. Its coordinate is x1, y1 and B is x2, y2. We draw AM perpendicular to x-axis and BN perpendicular to x-axis. As the lines are perpendicular, so these lines AM is parallel to BN. The distance between the lines is also equal. So here this is also equal distance as MN equal. So AC will be equal. This is equal to 90 degree. This is angle theta. This is also equal to theta. So this is an corresponding angles. So here we consider OM as x1 or ON as x2. So it means this will be x2 minus x1. So this will be equal to x2 minus x1. Here we consider BN as y2 and CN as y1. So BC will be equal to y2 minus y1. So in triangle BAC, where angle C is equal to 90, we get tan theta is equal to y2 minus y1 upon x2 minus x1. Here the tan theta, which is also equal to m, which is the slope of our line, so m is equal to y2 minus y1 upon x2 minus x1. So this is the formula to find the slope of a line passing through 2 points. Now let us come on another topic, which is condition for two lines to be parallel in terms of slopes. We consider coordinate axis x and y. We consider this is the line L1 which makes an angle theta 1 with the positive x-axis, and this is the line L2 which makes an angle theta 2 with the positive x-axis. So slope of L1 is m1 is equal to tan theta 1. The slope of L2 is, it implies m2 is equal to tan theta 2. As L1 is parallel to L2, it implies theta 1 will be equal to theta 2. Angle will be also equal. So it implies tan theta 1 is equal to tan theta 2. It implies m1 equal to m2. So it means that when the lines are parallel, so in that case slope will be parallel. So this is the condition for lines to be parallel in terms of slope. Now let us come on another topic, which is condition for two lines to be perpendicular. Here we will find the condition for the two lines to be perpendicular in terms of slopes. So we consider coordinate axis x or y. We consider line the L1, which makes an angle theta 1 with the positive x-axis, and this is the line L2, which makes an angle theta 2 with the positive x-axis, and both are perpendicular to each other at 90 degree. So here the slope of L1 is m1, the slope of L2 is m2. So here for two non-vertical lines are perpendicular to each other if and only if m1 into m2 is equal to minus 1. Means the product of the slopes of two lines will be equal to minus 1. So we can say that two lines to be perpendicular. This is the condition for the two lines to be perpendicular in terms of slopes. Now let us come on another topic, which is angle between two lines in terms of slopes. First of all, we consider two axes x and y. Here we have a line L1, which makes an angle theta 1, and this is the line L2, which makes an angle theta 2 with the positive x-axis. Both lines intersect each other at angle theta. This is also equal to theta, and we consider this is the phi angle. So the angle between two lines is given by tan theta is equal to mod m2 minus m1 upon 1 plus m1 into m2. Here theta is an acute angle, phi is an obtuse angle. To find phi, we have to consider 180 degree minus theta. 180 degree minus theta, so we can get the angle phi. So in question, if we have to find the angle between the two lines in terms of slopes, so our formula is tan theta is equal to mod m2 minus m1 upon 1 plus m1 into m2. So here to remove mod, we take tan theta is equal to plus minus m2 minus m1 upon 1 plus m1 into m2, and here we take tan theta is equal to positive m2 minus m1 upon 1 plus m1 into m2, and tan theta is equal to minus m2 minus m1 upon 1 plus m1 into m2, which will help to find the question and to find the angle between the two lines. Now let us come on the another topic, which is collinearity of 3 points. First of all, we consider the coordinate axis. Here we have a 3 points on a line which is A, B, C in the xy plane. Then they will lie on a line. 3 points are collinear if and only if slope of AB is equal to slope of BC. Means here A, B, C are the points on a line in xy plane. So these 3 points are collinear if and only if slope of AB is equal to slope of BC. If this condition satisfies, then we can see that ABC are collinear points. As we have studied about the concepts of slopes in this video lecture, so let us come on the fast recapitulation of the concepts. Recap. First is the slope of a line is given by m equal to tan theta. Second formula is slope of a line joining two points is given by m equal to y2 minus y1 upon x2 minus x1. Third is the angle between two lines is given by tan theta equal to mod m2 minus m1 upon 1 plus m1 into m2, where theta is an acute angle. Fourth is condition for parallelism of lines, of two lines, is slope will be equal to each other. Condition for perpendicularity of two lines is m1 into m2 is equal to minus 1. So I hope this video will help you to understand the concepts of slopes. Please revise the concepts at your home. Please stay at home and take care of yourself and of your family members.